All right, good day everyone. Welcome to this exciting lessons on YouTube chemistry tutorials. Okay, today we'll be looking at some past questions on the UTME exercise and some commonly repeated set of questions. Okay, we've been on this series for a while now. These questions, if they don't repeat them in the exam, they usually come out in this pattern. So it's a way of preparing you. And these topics are on mole concept and chemical bonding. More concept and chemical bonding. This is likely repeated questions. And let's quickly dive into the question. First question says, if 79 grams of a gas at STP occupies a volume of 25 cm3, what is the relative molecular mass of the gas? GMV at STP, or gas molar volume at STP, is 22.4 dm3. Now, I've said this in my previous videos. Okay, I've already said this in my previous videos. Now, at STP, if the question is relating mass and volume, there's a simple formula I've given you to solve. I've said at STP, it is relating mass, 79 grams of a gas. 79 grams of a gas at STP occupies this volume. Now, what is the molar mass of the gas? So it's containing mass and volume at STP. We know all that concepts. It's not a chemical reaction, so we cannot do stoichiometric relationship. Okay, so let's quickly solve it like this. So to solve this kind of question, I've given you a shortcut to solve it. It's mass over molar mass, or mass over molecular mass. So there's a difference between molecular mass and molar mass, but usually they are usually of the same value. Is equal to the volume of the gas, over GMV. Yes, it's equal to the volume of the gas over GMV. Okay, now quickly, what will be GMV? What will be GMV? GMV was given, which is 22.4. So what's the mass of the gas? 79. So 79 over we're looking at now over the molar mass, which is x, let's make it x, equal to, what's the volume of the gas? The volume of the gas is 25 over GMV, which is 22.4. So now at this point in time, we're looking for x. So if we make x subject of formula, we're going to have x equal to, by cross multiplying, so x can come up, so that's 25 goes down. So I have x up. Okay, let me just do it like this. So I have x equal to, now I have what's it called, 79 times, okay, 79 times 22.4 all over 25. So that will be x. So that will be the molar mass of the gas. So what will be the molar mass of the gas? So let me quickly calculate. I have 75 times 22.4 times 25. Sorry, pardon me. That's 1680 at the top, divided by 25. So I have 67.2. So the molecular mass of the gas is 67.2 AMU. As simple as that. It's so easy. Please don't forget, anytime you are connecting mass and volume, or even mole at volume at STP, obviously even if GMV is not given, you should note it 22.4 dm cube or 22,400 cm cube. So hope I'm not missing anything in the question. So this is 25 dm cube, pardon me, 25 dm cube. So this could not be in cm cube, and this is in dm cube. So this is 25 dm cube. Why 25 dm cube? Why 25 dm cube? 25 dm cube. Why should it be in the same unit? Because volume here will cancel volume here. If here was in cm cube, assuming here was 25 cm cube, this 25 was in cm cube, here would have been in cm cube also. Here would have been cm cube also, which is 22,400. So, okay, it should have been cm cube also. So this GMV in cm cube is 22,400. Okay, not 22.4. So this is the proper answer. Molecular mass of the gas. So that's all about the question. It's very simple. Also, this formula can be given as mass over molar mass, which is now moles. So I can call it moles equal to volume over GMV. So you can be asked moles. Okay, you can be asked moles. So calculate how many mole of a gas, or how many mole does a gas occupy when the volume is this at STP. Same question. Okay, this pattern of question, they are so common in the UTME exercise. Please, student writing the UTME and the post-UTME examination, please take note of this question. Okay, the next question is on chemical bonding. Now, the next question says, when two elements with close electronegativity value combine, they form, now what they actually form is that they form a type of bond. When the electronegativity difference is close, they form a type of bond. In my bonding video that I'm posting now, I'll put my bonding video very soon. Okay, in the bonding video that I'm going to drop, I'll tell you that when two elements with close electronegativity difference combine, the type of bond formed is called covalent bond. Okay? Usually electronegativity difference on the Pauling scale less than 1.7. So the electronegativity difference on the Pauling scale is less than 1.7. The type of bond they form is most likely covalent. If it's greater than 1.7, they form electrovalent bond. So that's that. Dative bond is a type of bond due to transfer of lone pairs of electrons between Lewis acid and the Lewis base. Dative bond is also called coordinate covalent bond. That's that for that. Okay. Why hydrogen bond is the type of bond that was formed when hydrogen is in combination with a very electronegative element. When hydrogen is in combination with very electronegative elements, which are of three. So it's usually an intermolecular bond formed when hydrogen is in combination with a very electronegative element, such as fluorine, nitrogen, and oxygen. That's for hydrogen bonding. Okay. The next one is question 3. So a compound that is readily soluble in organic solvent will likely contain. Now, most organic compounds, except for a few with ionic bond or electrovalent bond, most organic compounds usually have covalent bond in their structure. The bond found in most or 90% of the organic compounds are usually covalent bonds. They usually have covalent linkage. 90% of the organic compounds we know have covalent linkage. So for you not to even be soluble in water, one of the characteristics of covalent bonds is that covalent bonds are usually compounds forming covalent bonds are usually non-polar. So most of them are not soluble in water, with just a few exceptions. So for you to be more soluble in organic solvent means you're not very soluble in water. So it means you have covalent bond. Please take note of this. Covalent bond is most present in 90% of the organic compounds. Okay. Covalent bond only. Yes, I think all organic compounds should have covalent bond. Why covalent bond only should be found in 90% of almost all organic compounds. I've talked about dative bond earlier, transfer of lone pairs of electrons. Okay, dative bond can be seen, let's say, in the case of let's say ammonia and hydrogen ion. So you get ammonium. So the formation of ammonium is due to dative bond, or what we call coordinate covalent bond. Now, what about ionic bond? Ionic bond is also called electrovalent bond. It's formed between two elements with far electronegative difference. Okay, between something like sodium and chlorine. Okay, sodium and chlorine. Sodium is very electropositive, while chlorine is very electronegative. The electronegativity difference is far apart, so they have ionic bond. The metallic bond is found between the crystals of metals. Okay, metallic bond is a type of bond found between the crystals of metals. Okay, it is formed as a result of a pull or sea of delocalized electrons. So at this junction, we have to call it a day here. I hope this video was helpful. Just drop a comment and any parts you find uninteresting, or any parts you don't like or you want to correct or anything. But I doubt this video was excellent. Okay, so just make sure you like, subscribe to this channel, and until the next video, it's bye. So see you guys.